So let's look back at the fact that we just learned in the last video how to use a XY table to come up with some values for X and Y. And we're going to apply our linear equation formula to figure that out. So let's generate a table of values for each equation. Remember, I was telling you that we want to use -2 to +2 is just our general values that we use. So let's just list these here. And since we have space, we'll go to 3. So we're going to do that for both lists of X values. And we always start with the X value because we've solved for Y. And so Y is our output, okay? Over here, we'll see how that plays out differently. So -5 times -2, right? Because if X is -2, or not if, but when X equals -2, this is 10, right? +10, and 10 plus 22 is 32. When X is -1, we have +5 plus 22 is 27. When X is 0, we just have 22. And this is -5 plus 22 is 17. And you should start to notice the pattern on this side. We're decreasing by 5. So I can already just fill these in. Again, checking this last one just to be sure, -5 times 3 is -15, and -15 plus 22 is 7. Now let's do it over here. So we have -5, but when X is -2. So let's do what's in parentheses first. -2, right? Minus 4 is -6, and -5 times -6 is 30. So I'm just going to write this above for the first one. 30 equals some number minus 2. Well, we know that that must be 32 minus 2 equals 30, right? And if you're a little uncomfortable working this way, you could rearrange this, just as a side note. Solve for Y. That's why we did so much work with literal equations, is that we wanted to be able to be fluent with solving for different parts. So all we have to do is add 2 to both sides. And we get -5 times X minus 4, and then add a 2, and that gives you Y. So if you want to substitute it in after you've solved it this way, if that's easier, go ahead and do that. I can already tell in comparing these two equations that when X was -2, Y was 32, and that's the same over here. So I'm going to assume that it's going to be the same moving down, but let's prove it. -1 minus 4 is -5, times -5 is 25. Some number minus 2 equals 25. We know that's 27. So you're going to see the pattern here. 0 minus 4 is -4. -4 times -5 is 20. Some number minus 2 equals 20. That must be 22. So this is going to be the same. And we could have kept solving this to see that Y equals -5X plus 22 when we distribute and add the 2. They are in fact the same equations. Pretty sweet. So we have just moved from a slope-intercept form of an equation to point-slope form. Now, let's keep going. So now let's answer this question. What information does the point-slope equation of a line reveal about a line? Does it give us the slope? Does it give us a point on the line? How can you write the equation of a line using any points on a line? You can use the slope formula to find the slope, right? We did that. We had 2 points and we found the slope. Okay, so that's review. We can also write the equation of any line using any point and the slope. So this is the base formula of a line in point slope form. This is point slope form. And I hope you're writing this down. This is the base formula. Really what this is saying is y minus y1. So this is the point, right? This is the only point you're given. So you're given a point, you're given the slope, and you're going to write it in point slope form. We don't need to know the y-intercept to write the equation. We can solve to find it if we want to, but we don't need it. So that is super, super sweet.